In this video, we'll be going through GCE Paper 2, Question 1. The question reads, x plus 1 is a factor of the polynomial f of x, where f of x is x cubed plus 6x squared plus 11x plus 6. Factorize f of x completely. 4 marks. Sub 2. Let lambda be a real constant. Show that the roots of the quadratic equation 3x squared plus bracket open minus 4 minus 2 lambda bracket close x plus 2 lambda equal to 0 are real. So the first question says that x plus 1 is a factor of the polynomial and the polynomial f of x is cubic. So in order to factorize f of x completely, we need to use the long division method to break down the cubic function to a quadratic and a linear function, and then we further break down the quadratic to two linear functions, either using the quadratic formula, the factorization method, the trial error method, and so on. So let's begin. Now they said x plus 1 is a factor. It means that x plus 1 is going to divide the polynomial f of x completely with no remainder. Now the steps in which I'm going to follow to simplify this quadratic with this polynomial will be the same for any form of equation. So the steps involves taking the first term, dividing with the first term of the linear or the factor. So x cubed divided by x is going to give us x squared. So we simply write our x squared there. Now we take x squared times x. This will simply give us back x cubed. So this will give us x cubed. Now x squared times, we are now taking this x squared times this will give us x. So plus, like we can say 1x squared. So what do we need to do? We need to subtract. We need to subtract these two functions. So if we subtract x cubed minus x cubed is going to give us 0, and 6x squared minus 1x squared is going to give us 5x squared. So the next thing we need to do is to bring down this term. You know that the next term with its sign. So the next term is 11. So we need to bring down plus 11x, so that we are going to follow the same steps as we did with x cubed here. So 5x squared divided by x is going to give us 5x. So plus 5x. Now 5x times x is going to give us 5x squared. So 5x squared. Now 5x times 1 is going to give us plus 5x. So now we simplify by subtracting. So if we subtract this function, we are going to get 5x squared minus 5x squared is going to give us 0, and 11x minus 5x is going to give us plus 6x. So we bring down the constant term with its sign. So the sign in front of the constant term is plus. So we are going to bring it down to plus 6. So now 6x divided by x is going to give us plus 6. Now 6 times x is going to give us 6x. It's going to give us 6x, and 6 times 1 is going to give us plus 6. So we are going to subtract our final answer. So we are going to subtract this, so that 6x minus 6x is going to give us 0. 6 minus 6 is going to give us 0. Now when our final answer is 0, 0, therefore the steps in which we followed are correct because x plus 1 is a factor. Therefore, normally you should divide this polynomial, this cubic polynomial, with no remainder. So if you're solving and you discover that here is not giving you 0, 0, what you simply need to do is to go back to any of these steps and check if you made a mistake, because normally it should give you 0, 0 here, so that now you can finally write your polynomial as f of x equal to x plus 1 into x squared plus 5x plus 6. Now notice something. This is a quadratic, so we need to break this down into two linear functions by formula method, factorization method, try and error method, and any method that we use in factorizing or in breaking down quadratic. So if we use the factorization method, we see that we're looking for factors of 6 such that when we add them, it's going to give us 5, and when we multiply, it gives us 6. Or simply you use this method, we know that x squared can be written as x times x, and 6 can be written as 2 times 3. So if we cross this and we cross that, we see that x times 3 is giving us 3x plus x times 2 is giving us 2x. So adding the 2 is going to give us 5x, which is correct. Now x times x is x squared, and 2 times 3 is 6. Therefore we've simplified that. So our final answer will be f of x equal to x plus 1 and x plus 2 and x plus 3. So that's our final answer. Question 2 says that let lambda be a real constant. Show that the roots of the quadratic equation 3x squared plus bracket open minus 4 minus 2 lambda bracket close x plus 2 lambda equal to 0 are real. So let's just write this down. So we have 3x squared plus minus 4 minus 2 lambda x plus 2 lambda equal to 0. So if we look at this very well, we see that it is in a quadratic form. So this is the same as ax plus bx plus our c here. If we look at it very well, so our c will be this, our b will be all of this, so our b is all of that, and our a is 3. So to prove that lambda is real, we know that from the quadratic equation x equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So now if you don't know how to derive this equation or this formula, if you don't know how to derive this formula, then I'm going to put the link of the video above here. The link of the video will be above here. You can simply click on it. You watch the step-by-step ways in which I personally did a video on that, so that you understand what I'm saying here. So for this formula to work, b squared minus 4ac should be greater than or equal to 0, because we know that the square root of a negative number does not exist in a set of real numbers, even though it exists in the set of complex numbers. So here, for us to solve lambda in the set of real numbers, b squared minus 4ac should be positive or equal to 0 for us to get our solutions. So we are going to apply the concept here. So if we apply that concept here, we are going to see that our b is all of that, so we can factor out minus, so 4 plus 2 lambda. Now it was b squared, right? So this will be like minus 1 Now all that squared minus 4 into a. Our a is 3 and our c is 2 lambda. So we want this to be greater than or equal to 0. But since it's a proof, we are going to consider just the left hand side and we prove that it is greater than or equal to 0. So if we continue proving, we discover that if we expand this function, minus 1 squared is going to give us 1. So if we expand 4 plus 2 lambda, we are going to get 16 plus 4 lambda squared plus 2 times the product of this will give us plus 16 lambda. Now minus 4 times 3 is going to give us 12. Now 12 times 2 is going to give us 24. So minus 24 lambda. Great. Now minus 24 lambda. So if we rearrange this in the quadratic form, we are going to get 4 lambda squared plus 4 lambda squared. Now 16 lambda minus 24 lambda is going to give us minus 8 lambda plus 16. We see that 4 is common. We can factor out 4. We'll get lambda squared minus 2 lambda plus 4. So at this point, to prove that this is always positive or it belongs to real number, we are going to, or belongs to a set of real numbers, we are going to use the completing square method just as the steps in which I used in deriving the quadratic formula. So we are going to follow the same steps here, but in the place of a, b and c, we'll be replacing it with the value 1, minus 2 and 4. So I would like to make a comment here. I thank my brother and Elson who helped me to bring out the solution for this final part. So now let's go ahead. We'll factor out 4. So we have the coefficient of the x lambda squared here is 1. So this is lambda squared minus 2 lambda. So we need to take plus half the coefficient of x. Here in this case is lambda, right? Minus half the coefficient of lambda. All that squared. So doing this, we need to subtract this because there's no right hand side here. So we need to remove back, or we need to subtract this so that our equation should be the same. Plus 4. So here we have 4 in bracket. We discover that this will be a perfect square. This will be a perfect square. This will give us a perfect square, which is of the form lambda minus 1 all that squared. So if you are doubting, you can simply expand this function and go to my video. I'll still put the link above here. Just click on this link. You'll be able to see, you'll be able to understand why I did this in the step-by-step derivation of the quadratic formula. So all of this can be written like this: minus now this one is going to give us minus 1. Minus 1 squared is going to give us 1. So minus 1 plus 4. So this will be bracket close. So our final answer will be 4 into lambda minus 1 all that squared plus 3. So we are done. The conclusion here will be that since lambda belongs to the set of real numbers, then lambda minus 1 all that squared will be greater than 0. Because any number of lambda that we put here minus 1 and we square is going to be positive. Now adding this positive number with 3, so adding now this positive number lambda minus 1 all that squared plus 3 is always going to be 0. So from there we have proven that the roots of this of lambda will always be positive. That's our final answer. Okay guys, thank you for watching my video till the end. Please make sure you put in the comment section below, write any question or ask any question number you like me to make a video on. I'll be happy and delighted to do that. And please also make sure to like my video in order to support my channel.